Hello, in this video we're going to go over something called molecular geometry, right? Essentially, so far in this unit, we've been learning about molecules and the shapes and structures of molecules, right? So we've talked about the Lewis dot structure so far. We've also talked about bond line structures or molecules where we don't show the carbons or hydrogens. Today, through this lab, we're basically going to go over how do I draw a three-dimensional version of a molecule, in this case CF4, as shown here, right, on a two-dimensional sheet of paper like this, right? So mainly for those of you that are doing this online, don't worry so much about drawing this, but rather we're going to focus on identifying the name of this three-dimensional shape, right, of this particular molecule and other molecules, right? So that's the process of what we're going through today. How do we identify the name of this? And there are 4 steps to complete this. So I'll do 2 problems with you here, right? And from these 2 problems, hopefully you're able to do this section on your own. So the first thing we need to do is to identify the Lewis dot structure itself, right? So recall that to identify the Lewis dot structure, we're going to need the periodic table. And for those of you at home, feel free to use any type of periodic table, right? I just have a digital version of this one here. You can find this version by Google searching CST periodic table. Right. So recall that for nitrogen in group 5A, that's going to have 5 valence electrons. Oh, excuse me, we're doing CF4. So I first need to find C on the periodic table. Right. So carbon is in group 4A right here. And so therefore it's going to have 4 valence electrons going clockwise first. And then if I had more, I would go clockwise again. Right, so for F, if I looked up F on this periodic table, it's in group 7A, so it's going to have 7 valence electrons. Recall that I need to connect all of the single electrons on each side of the element. So F, after I draw it, I'm going to connect these 2 single electrons. Notice that there are 4 Fs, so I need to connect the rest of the Fs like so. Recognize that I'm skipping a lot of steps for the Lewis dot structure, mainly because this should be review and practice. So once I've identified the Lewis dot structure, I can move on to the second step, which is identifying the central atom. Right. So here, the central atom is just the atom in the center. So if I box this, right, C is my central atom. I'm going to pay attention to everything on the top and bottom and left and right of C or carbon, right? Mainly what I'm paying attention to is how the electrons are arranged around C. So electron domains essentially refer to how the electrons are arranged around carbon. Right? So electron domains can be a multiple things. They can be lone pairs, or the electrons that are paired off and not bonded to any other elements. They could be a single bond, a double bond, or a triple bond. Each of these counts for as one thing or one electron domain, right? So within carbon, there are 4 electron domains because there's 1, 2, 3, 4 single bonds here. So therefore, there are 4 electron domains. Notice I did not count the lone pairs surrounding fluorine, mainly because they are outside of the central atom, right? I only need to count the electron domains directly connected to the central atom. Once I've identified that, I also want to identify the number of non-bonded electron pairs or lone pairs, right? So again, looking directly connected to the central atom of carbon, or C, how many lone pairs are there? Well, of the 4 that I circled, none of them are lone pairs. So it's going to be 0 lone pairs. All right. So my third step is identifying how many electron domains and how many lone pairs are surrounding the central atom. Right. These two numbers will help me identify the molecular geometry and the molecular shape of the molecule. So recognizing the numbers is 4 for electron domains and 0 for lone pairs, I'm going to scroll down to page number 7, where I have kind of a cheat sheet that will help me identify the name of the geometry and the shape. All right, so notice earlier that we determined that we had 4 electron domains and 0 lone pairs, right? And if you noticed here in the table, 4 electron domains, 0 lone pairs, right? Therefore, the name of our molecular geometry of this particular molecule is tetrahedral and tetrahedral. Right, so scrolling back to the top portion, where my problems are at, I'm going to note that both of these are tetrahedral. So you might be wondering, if the answer is the same, why do I have these two? And that's because molecular geometry refers to the shape of the molecule, including the lone pair of electrons, while molecular shape does not include the lone pair of electrons. For those of you working at home, don't worry about completing the perspective formula for now. Okay, so for the second molecule, N2, I'm going to skip over explaining how to draw the Lewis dot structure, and let's just have that right here. So notice that for N2, there's not really a center in this particular example. So whenever I just have 2 elements, I can refer to both the molecular geometry and the molecular shape as linear, right? Think of it this way: as long as I have 2 atoms, right, no matter how many bonds that they have, whether it be 1, 2, or 3, there's really only one shape I can make with them, and that's essentially a straight line. So that would be linear. So for these 2 problems, hopefully that will help you out with the rest of them. Just to give you a couple of clues and hints for checking in, notice that Li2 is also 2 elements only. And for CS2, this would be my Lewis dot structure. And for HCN, this would be my Lewis dot structure. For H2S2, a small note to yourself is that I'm going to have you choose one of the sulfurs or one of the S's as the central atom. As always, if you have any clarifying questions, you can email me at qqun@slusd.us.